Hey guys, Mr. Middleton here. Today we're going to talk about solving literal equations, aka formulas. At the end of this video, you should be able to solve an equation involving multiple variables. Alright, so what's the goal when we solve an equation? Okay, no matter what, when we're solving an equation, our goal is to isolate a variable. Okay, remember, isolate just means get it by itself. We want to get a variable by itself. Okay, so what changes when there are multiple variables? Nothing really, except for the decision of what we're going to try to get by itself. So let's look at these two problems. So solve each of the equations below for x one step at a time. So we're going to go to this side. We have 2x minus 3 equals 15. Our question is what do we want to get by itself? X. What's stopping it from being by itself? The 2 and the 3. Okay, so what are we going to get rid of first? Well, we will get rid of this 3 first, and we'll do that by adding 3 to both sides. Okay, so we have 2x equals 18. Okay, we're going to do that same thing. I know we're not done with this problem. We're going to jump from left to right just so we can see what's happening. We're going to do that same thing on this right side. We have ax minus b equals c. Again, we're trying to get x by itself, and we're going to ask what's stopping it from being by itself. In this case, it's a and b. So we're going to get rid of the b first. B is subtracting, and so to get rid of it, we're going to add b. Okay, so when we add b to both sides, on our left side we still have ax. On our right side now we have, I'll just write it as b plus c. Okay, so after the first step, hopefully you notice that really what we did to get here didn't change at all, but when we got here our answer looks a little bit different. And the only reason is because 15 plus 3 is 18, but when you say b plus c, it's not like we can change that to a different, more simplified letter. It's just b plus c. Alright, and so now we go back to the left side and we're trying to get x by itself. What's stopping it? The 2. What's 2 doing? It's multiplying, and so to get rid of it we have to divide. And so we have x equals 9. On the right side, same question, what's stopping x from being by itself? The answer is a. What is a doing? It's multiplying, so to get rid of it, we divide by a. Okay, and so you'll notice again that our steps are the same, but when we get to our answer, we can't simplify all these letters unless we're given values for them, which we're not. Okay, so as we get through it, we see that even though our answers look different, the process is the same. So it's not anything new, really, to it, other than understanding that when we have a lot of variables, then we won't get a nice, clean, neat number, but we will be able to use the same process to isolate our variable. Okay, going to be really important through these problems that you remember or pay attention to what they're asking you to isolate or what they're asking you to solve for, and then just go through and ask yourselves those same questions. What's stopping it from being by itself? What operation is it doing? How do I get rid of it? Okay. So for this section, they're just saying solve for x. Each time they're saying solve for x. So for number 1, we're trying to get x by itself. What's stopping x from being by itself? Well, the 4 and the negative 3. I'm going to add 3 to both sides first. And so I have y plus 3 equals 4x. Notice that this is y. There's no way I can combine that to make it really nice. But I know it's going to be y plus 3. Okay, I want to get x by itself. What's stopping x is 4. 4 is multiplying, so I'm going to divide by 4. It'll cancel out on the right side. I'm just going to rewrite this so that x leads. And then I have, on the other side of the equation, y plus 3 over 4. Okay, if I could simplify this, I would. I can't, and so it's fine to leave it like this. X equals y plus 3. Okay. I am going to leave number 2 for you while I do the other ones. Please do number 2. Number 3, we have m over x equals 4n. Okay, again, the directions for this whole section say we're trying to get x by itself or solve for x. The toughest part I noticed about this problem is that x is in the denominator. So even though I want to get x by itself, I'm going to move it because when x is in the denominator, it really can't be by itself. There's always going to be 1 over it. So I'm going to multiply both sides by x. And what that will do, it moves x to the other side, but now I can get rid of the numbers surrounding it a little bit easier. Okay, and so now I see I have 4n next to x, and I want to get rid of that 4n. I can really do this in one step because 4 and n are both multiplying x. So I can get rid of it by dividing by 4n on both sides. Okay, and on the right side it cancels out. On the left side I have m over 4n. And so I can just write my answer as m over 4n. X is by itself. I've moved everything else by using inverse operations. There's my answer. Alright. Number 4, we have 13 minus 2x equals 25. Okay, so again, I'm trying to get x by itself. I'm going to ask myself what's stopping it from being by itself. Well, this 13. So I'm going to get rid of it by subtracting 13 on both sides. When I do that, I'm left with negative 2x equals 12. I'll then divide by negative 2. And so then I have my answer as x equals negative 6. Now look, because I had numbers, there's only one variable in this equation. My answer is just a number. X is negative 6. Okay, but it's the same process. We didn't have to change anything that we did because there weren't variables there. So the process is the same. Alright, let's look back here. A couple more examples back here. 3x minus 7y equals 12. Again, we're trying to solve for x. Okay, so I ask what's stopping x from being by itself? Well, the 3 and the 7y. So what do I get rid of first? Well, the 7y is subtracting from it, so I can just add 7y to both sides. So I have 3x equals, I'll write it as 7y plus 12. What's stopping x from being by itself? Now it's the 3. How do I get rid of it? I'll get rid of it by dividing both sides by 3. So my answer would be x equals 7y plus 12 over 3. Okay. That's one way I could write it. I could also, because I have 3 over both of these, and I see that I can simplify 12 over 3, I could write it as 7/3 y plus 4. Okay, because 7 over 3 y, 12 over 3 simplifies to 4. Either one of these are fine. Okay, my goal in showing you this is for you to recognize both of those answers. In the case that you saw it as a multiple choice and you're expecting to see this and wanted to see this instead. Okay. Okay. Alright. Number 6. We have z equals 2/3 xy. Again, I'm trying to get x by itself. I will start by asking what's stopping it from being by itself, and in this case the 2/3 and the y are stopping x from being by itself. They're both multiplying, but this 2/3 is a fraction. I'm going to deal with it separately than y. So y is multiplying it. I'm going to get rid of y by dividing both sides by y. And so I'll have z over y equals 2/3 x. Okay, now I need to get rid of that 2/3, and I'll do that by multiplying by the reciprocal. Okay, so I'm going to multiply both sides by 3 over 2. Remember, we do that because if we multiply this, we get 6 over 6, which is just 1x, which is great. Okay, so I have x by itself or 1x. And then on the right side I have 3z over 2y. And that's my final answer. X is now by itself. We've solved everything. Okay, so now you might say, when will this help me? This can help us if we're converting different equations or given different things. We can isolate different variables so we can see how to use the information we have or base an equation based off the information we have. Okay, so here's a real world example. We have, on her trip to Europe, Jane was told that the temperature in a certain area was an average of 30 degrees Celsius during the time she would be there. What clothes or clothing should Jane pack? So we have a formula for Celsius. Celsius is 5/9 Fahrenheit minus 32. Okay. So what if we want to go the other way? Notice that in this equation, Celsius is by itself. We really want to know what Fahrenheit is based off of Celsius degrees. So if we want to go the other way, we should solve for F. We want to get F by itself so that we can say, or plug C in and see what F will be. So let's figure out how to do that. We have this equation. Let's get F by itself. First thing that we should probably do is multiply by the reciprocal here. We want to get rid of this 5/9. The reason we don't want to distribute is because it's probably going to give us an ugly number, really, if we distribute that to both terms. So I'm going to multiply by 9/5 on both sides. Again, that gives me 45 over 45, or 1, so it's essentially gone. So I have 9c over 5 equals f minus 32. Okay, and to get f all the way by itself, I will add 32 to both sides. And so now I can have this equation, f equals 32 plus 9c over 5. Alright, and so when I say what clothes should you bring, all I need to do is plug c in here. And I can say 32 plus 9, and our degrees Celsius was 30 over 5. So 32 plus 270 over 5, that gives me 54, right? It's not 320. 32 degrees is what I was thinking. Okay, so what was that? Sorry, 54. 54 degrees, 32 plus 54. It should be 86 degrees. Where she's going is going to be 86 degrees Fahrenheit average temperature. Okay, so what should she bring? I don't know, swim trunks, tank tops, skirts, sundresses, not sweaters, not hoodies, not boots. Okay, so isolating for Fahrenheit made that a little easier to find. Okay, so that's where solving literal equations or solving formulas will be helpful. Those guys, not a whole lot of new stuff. It's just making sure that you ask yourself the same questions and focus on the variable that's important to us, or focus on isolating the variable that's important to us. Alright guys, hopefully now you know how to solve a literal equation or an equation with multiple variables in it. See ya.